In our last video about building a digit recognition CNN model, we created a small app for performing digit recognition. Today we are going to take that same app and transform it into a number recognition app, expanding its capabilities far from just recognizing individual digits. If you are new here and haven't watched that previous video in this series, I strongly advise you to do so because we will be building upon what we created in that video. I will leave a link to it in the top right corner for you to have a look at it. Assuming you have watched that video, let's dive into modifying the digit recognition project into one that recognizes entire numbers as the one you are seeing in the screen. First, let's have a fresh reminder of what we built so far, starting with the project structure. As you can see, we will continue from where we left off in the last video, with the accepts folder storing the digits and fonts folder, both containing the whiteboard image and the font used in the app. Additionally, there's the checkpoints folder to store the checkpoints from the model, the source folder with the Python files including the app, buttons, colors, config, font, model, and utils files, and finally the main file. Let's take a closer look at these files. The app file contains the Pygame application with the whiteboard. The buttons file contains the buttons configuration used in the application. The color file contains the colors used in the application. The config file contains some configurations that we will use in the app. And the font file contains some pre-declared fonts. The model file contains the CNN model implementation for training, testing, and making digits prediction. The utils file contains the smooth line function to smooth the lines drawn on the whiteboard. And lastly, the main file that runs the project with arguments to execute different actions such as training and testing the model or running the whiteboard application. So this is what we built in the previous video, and I strongly advise you to check it out. Now, you might be wondering what it would take to transform this digit recognition model into a number recognition model. Let's divide the problem so we can solve it. The dataset we used for the digit recognition model was the MNIST dataset, which contains 70,000 images of digits divided into train and test set. However, this dataset only works for training models for digit recognition. The logical solution here would be to use a dataset with numbers and not just with digits. But considering the infinitive nature of numbers, obtaining such a dataset is impractical. So what can we do? Let's consider an image from the whiteboard with numbers on it. If we look closely, we can take each digit from this same image. And by taking, I mean extracting. After extracting each digit, we can use the same model for digit recognition to predict its value. But wait, we know that the digits recognition model only accepts images of 28 by 28 pixels. Therefore, we need to place the digits on a whiteboard of 28 by 28 pixels and then pass it to the model. Surely this will work. To summarize, in order to transform this digit recognition app into a number recognition app, we need to identify the digits on the whiteboard, extract them one by one from left to right, place them into a 28 by 28 whiteboard, obtain the prediction for each digit from the digit recognition model, join the predicted values, and then we have the number written in the whiteboard. With this solution, we not only use the previous model but also solve the dataset problem, as obtaining a dataset with infinitive records is not feasible, and also training a model with a dataset with infinitive records is like impractical too. With this said, let's go back to the project files and create a new file in the src folder to implement what we just explained. We will call this file extract digits. In this file, to achieve our goal, we will utilize OpenCV and NumPy libraries to extract the digits from the whiteboard and place them into a new 28 by 28 whiteboard. We need to define a threshold for the aspect ratio and area to remove some black squares on the contours that are not digits. I'm going to create a function called getDigitsList. This function needs to be designed to extract digits from the given set of contours and prepare them for further processing. This function takes two parameters, contours, which represent a list of contours outlining the digits in an image, and openings, which are some processed image data. Hitting the function, we need to initialize an empty list named digitList, which is intended to hold the path to the extracted and processed digits image. Then iterate through each contour using a for loop, extracting relevant information such as bounding box coordinates x, y, w, and h, and calculating the aspect ratio and area for each contour. We need to apply certain conditions, such as checking if the aspect ratio is greater than the minimum aspect ratio that we declared in the global variable called mean aspect ratio, and if the area exceeds the minimum area threshold that we declared in the mean area global variable at the start in the beginning. If these conditions are met, then proceed to extract the digits from the opening image, resize it to fit into a 28 by 28 canvas, calculate the offsets to center the digits hitting the canvas because we need the digits in the middle of the canvas, and then place the digits into this 28 by 28 canvas with the digit itself represented in black. After processing each digit, this function saves the resulting image in a file based on its index in the digits folder that we have, and then appends the path to the digits list. Finally, it returns the digits list containing the paths to all the processed digit images. Then we need to create a new function called extract digits that processes an image containing multiple digits to extract and prepare them for further analysis. This function accepts a string called emg representing the file path of the image to be processed and returns a list of paths to the extracted digit images. First, it loads the image using OpenCV inRead function and converts it to grayscale to simplify subsequent processing steps. Then it applies a threshold to binarize the image, making digit regions stand out against the background. Then we need to apply an opening morphological operation to separate touching digits and enhance their individuality for contour detections. To find the contour, we will use the findContour function, which locates continuous regions of similar intensity. Afterwards, we need to sort the contours based on their x-coordinates to ensure that the digits are processed in a left-to-right order, which is essential to our task. And finally, the function calls the getDigitsList function with the obtained contours and the processed image data opening, returning the list of paths from the extracted digits. And finally, these extract digits file serve as a high-level interface for digits extraction, encapsulating the lower-level image processing step required for our task. Before going into the app.py file, we need to change the whiteboard size on the config file and change the white to be 600 instead of 300 pixels. Now back to our application file responsible for returning the whiteboard app. We need to update the getModelPrediction function after saving the whiteboard image represented by the whiteboard variable to a file named whiteboard.png into the digits directory to serve as input for the subsequent digit extraction process. Then we need to call the extract digits function to extract digits from the saved whiteboard image, in which the return from this function will be the digits list as we declared in the extract digits file, containing the paths to individual digits image. Next, we will initialize an empty string, we can call it number, to store the predicted number. We need to iterate through each digit image path in the digits list, and for each digit we need to get the predicted value using our digit recognition model by calling the model.predict function and append the predicted digit value to the number string. And finally, we convert the concatenated number string to an integer and then back to a string because we want to eliminate the zeros up front the number to get only the number and not the unnecessary zeros in front of the whole number, and then assign this to the predicted value. With this process, we will predict a number from the handwritten digits on the whiteboard using our model and update the predicted value with the predicted number as a string. Additionally, in this application class, we need to make an update on the predicted predicted draw value function, since now we have a number instead of a digits. The draw predicted value method is responsible for visually represent the predicted value on the whiteboard app. First, we have to calculate the font size required to render the predicted value on the screen using pygame.font.font.size, taking into account the font size defined by us in the font files and also the predicted value, and then determine the box size and store it in the box size variable, and the box position and store it in the box position variable, in which this will be the box in where we will display the predicted value on the whiteboard application. If the predicted value is empty, then we set a default height for the box to ensure visibility. If not, we set the height according to the font size. Next, we need to draw a rectangle representing the box on the screen using pygame.draw.rect. This box has a light gray field color and a purple border color. The border radius parameter rounds the corner of the rectangle. After drawing the box, it renders the predicted value text using the defined font and the purple color. The rendered text will then be bleeded into the screen surface at the position calculated based on the screen width and the font size and the position of the whiteboard. And now finally, we have everything ready. We can bring up our terminal. We could train the model again with the train model action, but there is no need to do that because we already have it trained. However, we can test it, in which we can see that this model performs really well at digit recognition. Then we can run the action to display the app and test it, and let it pop up the app for us to test the whiteboard. By drawing some numbers, we can see that it works well and satisfies our goal for predicting numbers. For example, I'm drawing 2345 and the model predicted it correctly. Another example is 6780. The model also predicted the number well. With other examples, the model continues to perform well. And of course, there are cases where it misses, and that can be improved. I will leave that to you as a challenge. If you made it this far, I hope you have enjoyed the content. If so, consider watching our videos from our channel and joining us for future content like this. Thanks for watching.